Department of Mechanical and Automation Engineering. I am going to present my lecture about power plant engineering. Power plant. This is the structure of power plant. Definition of power plant. A power station, also referred to as a generating station, power plant, powerhouse or generating plant, is an industrial facility for the generation of electric power. Unit collection of power plant. There may be several units which are described below. 1. Energy source, heat, wind, water, etc. Second one, turbine. Third one, generator. Types of power plant. Several power plants are available on the basis of primary source or fuel. Nuclear power plants, geothermal power plants, fossil fuel power plants, biomass fueled power plant, solar thermal power plant. Performance efficiency. All thermal power plants produce waste heat energy as a byproduct of the useful electrical energy produced. The amount of waste heat energy equals or exceeds the amount of energy converted into useful electricity. Gas-fired power plants can achieve 50% conversion efficiency, while coal and oil plants achieve around 30%. Cooling process, cooling tower. Normally, 3 types of cooling process are available. One is water cooled, second one is mechanical induced draft wet cooling, third one is air cooled. Water cooled. Many nuclear power plants and large fossil fuel fired power plants use large hyperboiled chimney like structures that release the waste heat to the ambient atmosphere by the evaporation of water. Mechanical induced draft wet cooling. Many power plants use fans to provide air movement upward through downcoming water and are not hyperboiled chimney like structures. Air cooled. In areas with restricted water use, a dry cooling tower or directly air cooled radiators may be necessary. These coolers have lower efficiency and higher efficiency consumption to drive fans compared to the typical wet evaporative cooling tower. Thermal power plant. This is coal-fired power plant. The components of thermal power plant is boiler, turbine, condenser, generator, chimney. Thermal power plant. A thermal power station is a power plant in which the prime mover is steam driven. Water is heated, turns into steam and spins a steam turbine which drives an electrical generator. After it passes through the turbine, the steam is condensed in a condenser and recycled to where it was heated. That is known as a Rankine cycle. This is the components of a thermal power plant: cooling tower, cooling water pump, transmission line, setup transformer, electrical generator, low pressure steam turbine, condensate pump, surface condenser, intermediate pressure steam turbine, steam control valve, high pressure steam turbine, deaerator, feed water heater, boiler steam drum, superheater, forced trapped fan, reheater, compression air intake, induced draft fan. This is nuclear reactor. A nuclear reactor is a device to initiate and control a sustained nuclear chain reaction. The most common use of nuclear reactor is for the generation of electric energy and for the propulsion of ships. The nuclear reactor is the heart of the plant. Hydraulic power plant. The production of electrical power through the use of the gravitational force of falling or flowing water. It is the most widely used form of renewable energy. Generating methods of hydroelectricity. Conventional, that is dams. Most hydroelectric power comes from the potential energy of dammed water driving a water turbine and generator. Pumped storage. The method produces electricity to supply high peak demands by moving water between reservoir at different elevations. Run of the river hydropower could provide potential to drive the turbine. Tide. A tidal power plant makes use of the daily rise and fall of ocean water due to tides underground. An underground power station makes use of a large natural height difference between two waterways such as a waterfall or mountain lake. Geothermal power plant. Geothermal electricity is electricity generated from geothermal energy. Technologies in use include dry steam power plants, flash steam power plants, and binary cycle power plants. Types of geothermal power plants. Dry steam power plants. They directly use geothermal steam of 150 degree or greater to turn turbines. Flash steam power plants. Steam plants pull deep, high pressure hot water into low pressure tanks and use the resulting flash steam to drive turbines. They require fluid temperature of at least 180 degrees centigrade, usually more. Binary cycle power plants. The moderately hot geothermal water is passed by a secondary fluid with a much lower boiling point than water. This causes the secondary water mass vaporize, which then drives the turbine. Then I am going to explain about nuclear power plant. Definition of nuclear power plant. A nuclear power plant is a facility that converts automatic energy into usable power. In a nuclear electric power plant, heat produced by a reactor is generally used to drive a turbine, which in turn drives an electric generator. This is fusion reaction. Two light atoms, that is deuterium and tritium, combine with helium and energy finally produce neutron. Principle. The basic principle of the performance of a nuclear power plant based on obtaining heat energy through the nuclear fission of the atoms nucleus from the fuel. Nuclear fuel. Nuclear fuel is any material that can be consumed to drive nuclear energy. The most of the common type of nuclear fuel is uranium 235 and plutonium 239. Nuclear fission. This is nuclear fission. Nuclear fission involving splitting the nucleus of an heavy atoms such as uranium 235 and plutonium 239, thereby generating heat, energy and neutrons. Structure of nuclear power plant. This is the component of nuclear power plants. Reactor vessel, fuel rods, control rods, steam generator, turbine, alternator, condenser, cooling tower and chimney. Nuclear reactor. A nuclear reactor is a device in which nuclear chain reaction are initiated and controlled. If it is not controlled, causing an explosion. Control rods. Control rods normally made of cadmium and boron, which is used to start the chain reaction and shut down during emergency. Steam generators. Steam generators, also called as heat exchanger, used to convert water into steam from heat produced in a nuclear reactor core. Either ordinary water or heavy water is used as the coolant. Steam turbine. A steam turbine is a mechanical device which converts thermal energy into useful mechanical energy. Various high performance alloys and superalloys have been used for steam generator tubing. Coolant pump. The coolant pump pressurizes the coolant to pressure of the order of 155 bar. Coolant pump is used to maintain the flow of coolant. Feed pump. Steam coming out of the turbine flows through the condenser for condensation and recirculated for the next cycle of the operation. The feed pump circulates the condensed water in the working fluid loop. Condenser. Condenser is a device or unit which is used to condensate the vapor into liquid. Advantages. Nuclear power generation does emit relatively low amounts of carbon dioxide, the emissions of greenhouse gas. Therefore, the contribution of nuclear power plants to global warming is therefore relatively little. This technology is readily available. It does not have to be developed first. It is possible to generate a high amount of electrical energy in one single plant. Disadvantages. The problem of radioactive waste is still unsolved. Second point is high risk. It is technically impossible to build a plant with 100% security. The energy sources for nuclear energy is uranium. Uranium is a scarce resource. Its supply is estimated to last only for the next 30 to 60 years, depending on the actual demand. Nuclear accidents leads to damage of lot of properties and human life. Next, I am going to explain about hydroelectric power plant. Hydroelectric power plant system convert the kinetic energy in flowing water into electric energy. Falling of flowing water turns a propeller like is called a turbine. The turbine turns a metal shaft in an electric generator which produces electricity. This is a schematic view of a hydro power plant. Reservoir, sluice gates, powerhouse which contains turbine, control system, advantages: no fuel required, no air pollution, can easily work during high peak daily loads, prevents floods. Disadvantages: disturbs the aquatic ecosystems, disruption of surrounding areas, requires large scale human displacement. How a hydroelectric power system works. Flowing water is directed at a turbine. The flowing water causes the turbine to rotate, converting the water's kinetic energy into mechanical energy. The mechanical energy produced by the turbine is converted into electricity using a generator. Inside the generator, the shaft of the turbine pins a magnet inside coils of copper wire. It is a fact of nature that moving a magnet near a conductor causes an electric current. This is HYDER, that is hydroelectric power plant. HYDER system, runoff plants without poundage. As name indicates, this type of plant does not store water. The plant uses as water comes. Second one, runoff plants with poundage. Poundage permits storage of water during the off-peak period and use of this water during peak periods. Reservoir plants. A reservoir plant is that which has reservoir of such size as to permit carrying over storage from wet season to the next dry season. Low-head plants. In this case, small dam is built across the river to provide the necessary head. In such plants, Francis type of turbines are used. Medium head plants. The forebay provided at the beginning of penstock serves as water reservoir for such plants. In these plants, water is generally carried out in open canals from reservoir to the forebay and then to the penstock. Peak load plants. These plants are mainly used during peak load. Runoff river plants with poundage can be used as peak load plants. Reservoir plants with enough storage behind the dam can be used either as base load or as peak load plants as required. Pumped storage plants. These plants are used when quantity of water available for generation is insufficient. If it is possible to pond at headwater and tailwater locations after passing through the turbine is stored in the tail race pond, from where it may be pumped back to the headwater pond. Low head plants. In this case, a small dam is built across the river to provide the necessary head. The excess water is allowed to flow over the dam itself. In such plants, Francis, propeller or Kaplan types of turbines are used. Also, no surge tank is required. These plants are constructed where the water head available less than 30 meters. The production of electricity will be less due to low head. This is low head plant, head race, dam, powerhouse, finally tail race. Medium head plants, mainly forebay provided before the penstoke, act as water reservoir for medium head plants. In these plants, mainly water is carried through main reservoir to forebay and then to the penstoke. The forebay act as surge tank for these plants. The turbines used will be Francis type of the steel encased variety. This is medium head plant, water from main reservoir, head race, forebay, penstoke, powerhouse and tail race. High head plants. Mainly in these plants, pressure tunnel is provided before the surge tank, which in turn connected to penstoke. A pressure tunnel is taken off from the reservoir and water brought to the valve house at the start of the penstokes. The penstokes are huge steel pipes which take large quantity of water from the valve house to the powerhouse. The valve house contains main sluice gates and in addition automatic isolating valves which come into operation when the penstoke bursts, cutting further supply of water. Surge tank is an open tank and is built just in between the beginning of the penstokes and the valve house. In absence of surge tank, the water hammer can damage the fixed gates. In majority of dams, sluice gates are provided. These sluice gates are opened when dam level is below level and there is shortage water for irrigation. Normally, the high head plants are 500 meters above and for heads above 500 meter Belton wheels are used. This is high head plant, reservoir, dam, tunnel, surge tank, penstoke, powerhouse and tile race. Components of hydel scheme. The principal components are forebay, indexed structure, penstoke, surge tank, turbines, powerhouse, draft tube tail race. This is the full view of hydroelectric power plants. 4 bay. Enlarged body of water provided in front of penstock, provided in case of runoff river plants and storage plants. Main function to store water which is rejected by plant. Powerhouse located close to dam. Penstock directly take water from reservoir. Reservoir acts as 4 bay. Intake structure. The main function of intake structure is to divert water from the reservoir into penstock. Penstocks. It is a large pipe that transports water under high pressure from the reservoir to the turbine. Penstocks gates are fixed to initial of penstocks and flow of water is controlled by operating penstock gates, either buried in ground or kept exposed. Surge tank. Surge tank is very small tank connected to the penstock to reduce pressure fluctuations and prevent water hammer effect. Such tank overcomes the abnormal pressure in the conduit when load on the turbine falls and act as a reservoir during increase of load. Turbines. Turbine is a machine which converts hydraulic energy into mechanical energy. Water turbine is a rotary engine that takes energy from moving water. Since the runner is spinning, the force acts through a distance this way. Energy is transferred from the water flow to the turbine. The principal types of turbines are impulse turbine and reaction turbine. Impulse turbine mainly used in high head plants. The entire pressure of water is converted into kinetic energy in a nozzle and the velocity of the jet drives the blades of turbine. The nozzle consists of a needle and quantity of water jet falling on the turbine is controlled. This needle placed in the tip of the nozzle. If the load on the turbine decreases, the governor pushes the needle into the nozzle, thereby reducing the quantity of water striking the turbine. Examples of impulse turbines are Burton wheel turbine, Turgot turbine, Michael Bankey. It is also known as the cross flow turbine. This is Burton wheel turbine. Reaction turbines are mainly for low and medium head plants. In reaction turbine, the water enters the runner partially with pressure energy and partially with velocity head. Most water turbines in use are reaction turbines and are used in low and medium head applications. In reaction turbine, pressure drop occurs in both fixed and moving blades. In this turbine, the runner blades change with respect to guide vane opening. As the sudden decrease of load takes place, the guide vane limit decreases. According to that, runner blade closes. Examples of reaction turbines are Francis turbine and Kaplan turbine. This is Francis and Kaplan turbine. Draft tube. A pipe connected to the turbine outlet that allows the turbine to be set above the tail race without losing head and increasing efficiency. Powerhouse. Powerhouse contained turbine, generator, transformer and control systems. Tail race. It is a channel that carries water away from the turbine back to the river downstream. Power generation. The amount of electricity that can be generated by a hydro power plant depends on two factors. Flow rate, the quantity of water flowing in a given time. Head, the height from which the water falls. The greater the flow and head, the more electricity produced. Flow rate, the quantity of water flowing. Head equal to the height from which water falls. A standard equation for calculating energy production power is equal to head into flow into efficiency divided by 11.8. Power, the electricity power in kilowatt. Head, the distance the water falls measured in feet. Flow, the amount of water flowing measured in cubic feet. Efficiency, how well the turbine and generator convert the power of falling water into electric power. This can range from 60%, that is 0.60, for older purely maintained hydro plants to 90%, that is 0.90, for newer well-maintained plants. 11.8 is equal to index that converts units of feet and seconds into kilowatt. Power is equal to 35,051 kilowatts. Thank you.